This is a quick lesson on equivalent decimals. It's just about numbers that look different but have the same value. So let's see what this means. All right, we're going to start this off by a simple question. If I were to give you $4 or I were to give you $4, which would you rather take? Well, they're both the same, and you can see that, but they're written differently. And that's what we're going to talk about today, is the fact that numbers can be written differently but have the same value. All right, to show an example of this, I'm just going to start with the number 4.1. When I look at 4.1, it can be written many different ways. It can be written 4.1, 4.10, which we often see in money, and 4.100. All of these are the same number. They have the same value. 4.1000. All of these have the same value. They're equivalent, and it's because these zeros that appear after a number with value or a digit with value in the decimal places, these zeros have no value, so they don't add anything to the number, so it still remains 4.1. When I take a look at these two equivalent decimals, I can see that 4.6 is equal to 4.60, because this 0, like we talked about, is worthless. It has no value at all, so it doesn't add anything to this number. It keeps it as 4.6. So it reads differently and it looks differently, but it means the exact same thing. Again, when we look at these numbers, we have 5.02 and 5.020. Since there is just a 0 on the end here after our 200ths here, that 0 has no value, so these are equivalent. 5.02 is equivalent or equal to 5.020. When I look at these two numbers, 9.480 and 9.48, these also are equal to each other because this 0 again has no value. So 9.480 is equal to 9.48. This is a bit of an exaggeration, but it's good to show this. If I have 6.57000, this is equal to 6.57. All these zeros have no value, so they just count as nothing. So 6.57000 is equal to 6.57. Okay, right now we are going to compare the black number at the top, 3.17, with the red number down here, 3.017, and the blue number, 3.170. In both colored numbers, you can see that there has been a 0 added into the number somewhere. In this one here, it's in this column in the middle of the number, in the tenths, and in here it's in the thousandths column at the end of the number. And that makes a big difference, and we're going to find out why. First, let's compare the red number. We're going to do a place value by place value to see if it is equal, and we'll see why the 0 may or may not work in this number. So we have 3 in our ones column, and here we have 3 in the ones. So far, it's equal. When I move to the tenths column, I have 0 tenths, and in this one I have 1 tenth. I now know that this is not equal because 0 tenths is not the same as 1 tenth. So this is not an equivalent decimal. I'm going to use the same method with the blue number here. When I take a look at my 3 in the ones, it matches with the 3 in the ones of this number. I'm going to see the tenths, and the 1 tenth matches with 1 tenth. I'm now going to take a look at the hundredths, and the 700ths matches with the 700ths. Now I'm going to match the thousandths. There's 0 thousandths here, and this is a blank thousandths. Technically, there could be a 0 in there because it has no value. So 3.17 is the same as 3.170. And now that you know what an equivalent decimal is, you're ready to move on. Good luck.